Right, hello. Let's do a recap on lesson one. And this is for the GCSE higher. Right, so first of all, we looked at types of numbers. Types of numbers. And all sorts of different types. We've got whole numbers. And whole numbers, 1, 7, 24, could be minus 32. Yeah, all sorts of things. As long as they're whole numbers, there's no bits. And these are called integers. And then we had fractions or fractional numbers. 1/3, 2/5, 3 1/4, or -2 1/2. All sorts of fractions. Percentages, 23%, -12%, sort of thing. Oh, you could have a combination, couldn't you? You could have -2.5%. So a fractional percentage. And decimals, 2.4 -3.8, 3.142, that sort of thing. And we will later on look at how to convert between all these fractions, percentages, and decimals. There are other, I can come down a little bit, there are other kinds of numbers that we can look at, and our square numbers, call that squares, and cubes. Now squares are written like this, 4 with a little 2 at the top, so that denotes, the 2 denotes a square number, and that means that it's this big number times itself. So 4 times 4, which equals 16. So 4 squared is equal to 16. 6 squared would be 6 times 6 is 36. Cube numbers, 4 cubed. Yeah, we have a little 3. And this, we usually use this in volumes. We'll come on to that later. So this means 4 times 4 times 4, which is 64. Then we've got square roots. And this is written like this. And what you need to find here in order to work out what the square root of 16 is a number times itself that equals 16. And it happens that 4 times 4 is 16. We've got it up there, look. So the square root of 16 is 4. And this one here, the square root of 36 is equal to 6, because 6 times 6. You've got cube roots as well. Just one cube root would do. Cube root. Now the cube root, in order to tell the difference there, we put a little 3. We don't bother putting a 2 on the square root, but we put a 3. And if we say the cube root of 125 would be something times itself, which equals to 125. And this equals 5, because 5 times 5 is 25, times 5 is 125. So the cube root of 125 is 5. Now there is one other little awkward bit here. We've got square roots. Now if we know that the square root of 16 equals 4 and the square root of 25 equals 5, there's a lot of numbers in between here. So if we say the square root of 20 is somewhere in between 4 and 5, but we don't really know what it is. 4 point something times 4 point something equals 20. And it's in between 4 and 5, so we don't know what it is. And that is what a surd is. A surd, S-U-R-D. A surd is a square root that doesn't come out to be a whole number, an integer. That's all it is. We might later on look at how to multiply, divide and add surds. There's special tricks, but it's I don't know, I think it's about a level 7 or level 8. It's quite a difficult thing to do. And all these sorts of numbers come into rational and irrational. Now, rational numbers can always be converted to a fraction. In simple terms, rational numbers are whole numbers. They're finite. You can write down a rational number. For example, even a quarter is a rational number because it's a specific amount. 3 is a rational number, it's a specific amount. The square root of 16 is a rational number, it's a specific amount. Now, irrational numbers, the best example of this is the number pi. Now, this is 3.14. We use this when we're working with circles, areas, circumference, and all sorts of things to do with circles. 3.1428 blah 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 blah. It goes on forever. Now, because it goes on forever, it's not a specific amount, so we would call that an irrational number, and that's the only one we need to worry about. Now, there is this, a third, which equals 0.333333 and so on. Now, this number never ends, but because we can write it as a fraction, it becomes a rational number. A rational number is a set amount, irrational number isn't. Right, because we can write it as a fraction. So then we went on to, or now we're going on to, just reminding ourselves how to add, subtract, divide, or multiply first. Multiply and divide. I wish I used the symbols, but never mind. It's what we did. It's what you do. So 28 plus 43. Yeah. Keep them in columns. Keep them nice and organized, and work from the right. So we add the 8 and 3 together, which gets 11. So we put the 1 there and we carry 1 over into the next column. So that means 1 in this column and 1 in this column. So we've got 1 in the tens column and 1 in the ones column. Then we add the 2 and the 4 together, which makes 6. And don't forget the 1 down there, which makes 7. And that's all there is to it. All there is to it. Subtraction, a little bit more tricky. If we have, let's say, 65 minus 23, this is easy. Again, we start from the right-hand side and we work our way across. And we go 5 subtract 3 is 2, 6 subtract 2 is 4. No problem whatsoever. Yeah. But when you have this, 62 minus 23, you go 2 minus 3. Can't do that. Yeah, we can't put a minus 1 down there. So what we have to do is 62 is made up of 6 times 10 and 2 times 1. Yeah, that is 60 and that is 2. So add that together, that makes 62. That's how a 62 is made up. So what we do is we borrow 1 from there, so we call that a 5, and we put the 1 there. So now we've got 5012, as it were. So 5012 is made up of 5 times 10, which is 50, and 12 times 1, which is 12, and you add them together and you still get 62. So we've not changed the value of the number on the top. So now you can do 12 take away 3, which is 9, and 5 take away 2, which is 3. So you borrow 1 from the next column along. Now there is an occasion where 602 minus 23 and 2 take away 3, we know we can't do it, so we'd like to borrow 1 from next door here, but there isn't anything there. So then you keep knocking on all the doors down the street until you get to one that you can borrow from. So we borrow 1 from the hundreds column here. So we'd call that 5, and we stick that on there to make that 10. See, now if we go back to the 2, we can borrow from this one. So we can borrow 1 off the 10, so we would call that 9 and then put that one there. So now we can do 12 take away 3, which is 9, and 9 take away 2 is 7, 5 take away nothing is 5. So if there's nothing to borrow immediately to the left of the number you're looking at, keep going, keep going. It could be that you get this sort of mad thing there where you want to just take away 3 and you go, I can't do that, I can't borrow there, and I can't borrow there, and I can't borrow there, so I'll borrow 1 off there. So you'd call that 5, and that would be 10, and then call that 9, and that would be 10, call that 9, and that would be 10, and call that 9, and that would be 12. So then you could go 12 take away 3 is 9, 9 take away nothing is 9, 9, 9, and 5. Yeah, just add that 3 back on, and you're going to get 9 and 3 is 12, 9 and 1 is 10, 9 and 1 is 10, 9 and 1 is 10, 5 and 1 is 6. So you get back to where you started from. So that's subtraction. Then the next little thing we did was multiplication. So 23 times 13. Okay. So you start from the right hand side again, and you're going to multiply by the 3 first. Every number at the top multiply by 3. Then you're going to multiply by this number 1, which really is a 10, because it's 10 and 3 make 13. So you do 3 times 3 is 9, and put your answer underneath there. So you do that, and then you do 3 times 2 is 6. Then we're going to multiply by the 1. So because we've moved along a column, we've got to put a 0 so that our first answer comes below the 1. And this is called a place marker. It's very important. Most important number we've got is 0, because if I owe you £10, yeah, the 0 counts, because if I didn't have a 0, it would just be £1. So the 10 does make a difference. It's important, especially if I put another 0 on the end, then I owe you £100. So this is why the 0 is the key to this. So then we go over to the 1 and we multiply it again by the 3. We're always going from right to left. So 1 times 3 is 3. So that's going to go down there. And then 1 times 2 is 2. And then we have, as has been called, a sandwich. And we're going to add these two bits together. So 9, 9, 2. That's how you multiply. Now, what happens if we've got 84 times 53? Yeah. Right, so 84 times 53. So we start with the 3 and we go 3 times 4 is 12. But 12, that's a double digit. Yeah, what do we do with this? Well, same as when we're adding, we put the 2 there and we've got 1 to carry over. Then we do 3 times 8, which is 24. Add the 1, which is 25. Now we're going to move along to the 5, and remember we need a place marker. So 5 times 4 is 20. Ignore that because we've already used that. So we got 0 there, and we carry 2 over. And 5 times 8 is 40, plus the 2, which is 42. And now we can add the two numbers together. So 2 and 0 is 2, 5 and 0 is 5, 2 and 2 is 4, 4 and on its own is 4. So that's multiplying. Next step up is division. Lots of dots there. Now division. The way I've learnt this is a bus stop method. It's just a pictorial. If we're going to do, let's do a number that works out first. Yeah. So we're going to have 224 divided by 4. Right. So what we do is we make our bus stop here, yeah, and we put the 224 inside there, and we put the 4 outside. Now this time we're working from left to right. So what you do with the 4 is you try and divide the 4 into each of these numbers in turn, and your answer will be on the top. So if you go 4s into 2, they don't go. So you could put a 0 there just to keep things tidy. You don't need to put the 0 in your answer, as we'll see. So now we can't just ignore that 2 just because it didn't go in. What we've got to do now is go 4 into 22, and 4 times 5 is 20. So that's the nearest we can get. So we put 5 there. So 4 5s are 20, but we've got 2 left over. Can't ignore that, so I'm going to put the 2 there. So now we go 4s into 24, and 4 6s. 4 times 6 is 24. So 4s into 24 goes 6. And your answer there, we can just lose the 0 now, is 56. And that's how you divide. Let's do another one. Oh, that's not enough, is it? Let's have a look at 8. So 104 divided by 8. Right. So 8s into 1 don't go. 8s into 10 go once, because 1 8 is 8. There's 2 left over. So we'll put the 2 there for the 4. 8s into 24 go 3. And I'm doing it with nothing left over because we'll come on to that later with decimals and remainders and things like this. So just work from the left over there, and that's how you divide. So then we went on, then the next thing here. I hope this is not going to be too long. I think it is, yeah. But it was a 3-hour lesson. So BIDMAS. This is the order that we do things in. So we've got brackets is the B, indices is the I, divide, multiply, add, and subtract. Brackets are these things, yeah. Indices are when we've got, I'll put an X because it can be any number. That is in indices, this little square sign, or the square root, indeed, is in indices. Don't worry about the X. X just means any old number you like. Bit of algebra there, yeah. So this is what indices are, these two things. And these numbers can be, 3, 5, 10, 20, minus 2, anything. So this is the order that you'd have to do things in. So we look at, say, just 3 examples, yeah. So we've got 2 plus 6 squared divided by 3. Right, so the first thing we've got to do is the brackets. In order to get rid of the brackets, we've got to do everything inside the bracket, which is 2 plus 6, which is 8. And don't forget the little squared bit on there, minus 3. Now 8 squared is 8 times 8, which is 64, minus 3 equals 61. Another example could be something a bit more complicated, yeah? 5 squared minus 4 times 36 divided by 6. Right, so brackets first. So don't forget, you can write this down in the corner of the paper all the time so you can remember. 36 divided by 6 is 6, and then I'm going to write all the rest of this stuff, yeah? So the next thing, it'll be the indices. So 5 squared. So I've got 25 minus 4 times 6. Then I'm going to do the multiply before I do the subtract. So 4 times 6 is 24. So 25 minus 24 is 1. Big mass. You must remember the order that you do things. Right. Then we looked at factors, or we shall now look at factors. Yeah. So factors. Factors are all the numbers that divide into something. So if I take the number 24 and I write it like that, all the numbers that multiply to get 24. So we can have 1 times 24, 2 times 12, 3 times 8, and 4 times 6. So all these numbers are factors of 24. So we can have 1 times 24, 2 times 12, 3 times 8, and 4 times 6, all written in the right order. So factors are all the numbers that go into 24. And if I do the factors of 16, it's 1 times 16, 2 times 8, and 4 times 4. I don't have to write the 4 twice. And when we've got two numbers, you will be asked to find the highest common factor, all often written like this, HFC. Now the highest common factor is a factor that is common to both numbers, in this case 24 and 16, and we're looking for the highest number that is common to both. And so the biggest number that goes into 24 and 16 is 8. So 8 is the highest common factor. So if I do 30 and 12, I'm going to find the highest common factor. So 1 times 30, 2 times 15, 3 times 10, 5 times 6. So there's all the factors of 30, and 12 is 1 times 12, 2 times 6, and 3 times 4. So the highest common factor is the biggest number that appears in both sets of factors, which is this one, 6. So there's the highest common factor of 30 and 12, which is 6. Now, the next bit is the lowest common multiple. Now, other way around from factors, this is just basically what, in primary school parlance is the times tables. Yeah, that's all this is. Yeah, so multiples. So if I do the 4 times table, yeah, and I do all the multiples of 4, I'm going to go 4, 2 4s are 8, 3 4s are 12, 4 4s are 16, 5 4s are 20, 6 4s are 24, 7 4s are 28, and so on and so forth. Now, if I do the 6 times table, I go 1 6 is 6, 2 6 are 12, 3 6 are 18, 4 6 are 24, 5 6 are 30, and 36, so on and so forth. So these are multiples of these numbers on the left, the 4 and the 6. Now, if we're looking for a common multiple, it's a number that appears in both sets. If we're looking for the lowest common multiple, now we're looking for the smallest number that appears in both sets, and it's this. So 12 is the lowest common multiple of these two. Now, 24 is a common multiple, but it's not the lowest. You're looking for the lowest. So there's the difference between highest common factor and lowest common multiple. Now, first of all, when we were looking at factors, is another important set of numbers is prime numbers. Now, prime numbers, see how the number 4 and the number 6 have lots of factors, or lots of multiples, sorry. Oh, let's have a look. So if I take 10, the number 10, the factors of 10 is 1 times 10 and 2 times 5. If I take the number 7, the factors of 7 is 1 and 7. Now, because this number 7 only has factors of 1 and itself. Yeah. So if you have a number that when you look at all the factors of that number, you can only find that it will be 1 times itself, then this becomes a prime number. Okay, so we've got the prime numbers. There is one caveat on this, that the number 1, for some reason, is not a prime number. Is not a prime number. But from there on is 2 has a factor of 1 and itself, 3, 5, 7, 9, 10, 11, 13, 17, and I think 19, and 23. Obviously, we don't know how many there are, but they will go on forever. And the bigger they get, the harder they are to work out. So all of these numbers here have only got factors of 1 and themselves. For example, 13. 1 times 13, but nothing else will go into it. So these are a list of the first several prime numbers. And if you can remember up to about 13, you'll be fine. So when we're looking at factors of numbers, we can just look at prime factors. And prime factors. So if we do this number 20, or let's do a better number than that, 30, 36, I suppose, yeah. So it's 1 times 36, 2 times 18. I don't know whether this is going to work with an even number. 3 times 12, 4 times 9, 5, 6 times 6, that's it. So there's all the factors of 36, and the prime factors are going to be 2 and 3. Yeah, because it's an even number, you don't get too many odd ones. Yeah, so 2 and 3 are there, so they are prime factors. So not only have we found the factors of 36, we've also, as a byproduct, worked out the prime factors. Now there's a great way of working out prime factors using something called a factor tree. Now a factor tree is just a pictorial way of breaking down a number into its prime factors, and we'll see. So what did we do there? The number 36. So let's do the number 36. So what you do with the number 36 is, 36 has all these factors, and you can pick any two numbers that multiply together to make 36. And I'm going to go 2 times 18. Now, when you get to the end of this little branch, it's sort of like a family tree, isn't it? There's the parents and here's some children. When you get to the end of a branch, and you happen upon a prime number, ring round it. Yeah, 2 is a prime number, ring round it. But this one here, the number 18, you can factorize this further. You can go 2 times 9. Now here is another prime number, 2. So stop there. Now factorize 9, 3 times 3. Now here and here are prime numbers. And if we take all these numbers, 2 times 2 times 3 times 3, we can see that this is 2 times 2 is 4, times 3 is 12, times 3 is 36. So we've used prime numbers, the factors of 36, as prime numbers to make 36. So we've found out the prime factors of 36. Now, you'll get this sort of question and they will ask you to write this in index form. Now what index form is like, remember we had 3 squared and 12 cubed. You know, that's index form when you've got a little square and a little cube. So if we look at these numbers here, see we've got 2 lots of 2. So instead of writing 2 times 2, we can use that and write that as 2 squared because it means the same thing, but it's in index form. And the same over here, we've got 2 3's, so we can write that as 3 squared because this will be 4 times 9, which is 36. So there's one that you're going to write. You've used the factor tree and you've written your answer in index form. So we'll just do one number before we wrap up on this one because it's a lot longer than what I thought. Half an hour's worth. But you can watch it double speed. Yeah, that's okay. So it doesn't matter. So let's look at this number. This is huge. How can we find the prime factors? Express this number as prime factors in index form. Last one. Now remember, we can use any numbers we like. Now because this ends with a 0, I'm going to go 42 times 10. Yep. Now over here I can factorize this. I can go 2 times 5. And remember, 2 and 5 are prime numbers. So we'll ring round them. Now 42 is 6 times 7. 6 times 7. Now 6 is not a prime number, but 7 is. And 6 can be written as 2 times 3. And these are both prime numbers. So now if I put them all in order, I've got 2 times 2 times 3 times 5 times 7. And then I put them in index form. And these 2's become 2 squared times 3 times 5 times 7. There you go. And if you multiplied all this up together, hopefully we get 420. Let's have a look. 4 times 3 is 12. 5 12s is 60. 60 times 7 is 420. So it doesn't matter how big the number is. You can break it up nice and easily. And the good thing about this is if you didn't know what this is, you could have done 420 and you could have just gone 2 times 210, yeah, and then you could have gone 2 times 105 and 5 times 21 and 3 times 7. So you've gone a completely different way, but look, 2 times 2 times 3 times 5 times 7. You get exactly the same numbers. Okay, that was long. End of that lesson. All right, see you in the next one.